Solving simple equations, chapter 1, section 3. I know in section 2, when we were doing the cube roots, we had some equations that were pretty hard order of operations. And we're now running all the way back and starting with simple equations. I like calling them simple equations instead of one-step equations because you can solve an equation in a lot of different ways. These are just a simpler version of equality. An equation is a statement that two expressions are equal. For it to be an equation, it has to have an equal sign. If it's just numbers and letters adding and multiplying together in some way, that's just an expression. A linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are constants and a is not equal to 0. A solution of an equation is a value that makes the equation true. We find those solutions by getting the variable that we want by itself. Inverse operations are two operations that undo each other, such as the addition and subtraction, multiply and divide, square root and square, cube root and cube. Those are all inverse operations. I'm going to shrink this down a little bit right here so we can actually see what's going on with it. All right. When you perform the same inverse operation on each side of an equation, you can produce an equivalent equation. An equivalent equation is an equation that is equal to another. They are equations that have the same solutions. Now, we can create equivalent equations using properties of equality, because as long as we keep it equal, then it's still the same value. So, the addition property of equality allows you to add the same amount to both sides. So if we have something that says A equals B, we are allowed to add C to both sides as long as we do it to both sides equally. It's kind of like a balance. If you add 5 pounds on the left side, it's going to come crashing down unless you add 5 pounds on the right side. So as long as you do it equal, it will stay balanced. Same thing with the subtraction property of equality. As long as you subtract the same amount from both sides, then they are still equal. So let's put that in practice. Now, solve each equation, justify each step, and check your answer. It's got 3 things for you to do. We'll probably go easy on the justify each step whenever we come to our homework, but I will write the justification for a couple of these so you can see what's going on. All right. Solve each equation, justify each step, check your answer. X minus 3 equals negative 5. All right. Well, we want to get the x by itself, so that means that we need to get rid of the minus 3. To get rid of things, we do the opposite side, or the inverse operation. So opposite of minus 3 would be, need a pen, hello, be plus 3. If we do it here, we must do it there. That is the addition property of equality. That's our justification. Negative 3 plus 3 is 0, which leaves us with just x. And negative 5 plus 3 is a negative 2. Now, if we check our answer, we do negative 2 minus 3 equals negative 5. That's getting more negative. Negative 2 and negative 3 makes negative 5. Checks out. So there's our answer. Works the same with decimals. Even it works if your variable is on the right-hand side. We've got 0.9 equal to y plus 2.8. Excuse me. We want to get the y by itself. So we're going to take away the 2.8. Do it from both sides so it stays equal. That's the subtraction property of equality. Okay, so that leaves us with y on the right. And when we do a subtraction here, 9 minus 8 is 1. Don't know why I put a 7 there. And 0 minus 2 is negative 2. So we should have negative 2.1. If we take 0.9 and we do negative 2.1 plus 2.8. To add those together, it actually works like a subtraction. So we do 2.1, 9, 0, 0.9, that checks out, so it works. This should be pretty familiar to you from pre-algebra. You would call these one-step equations. I just call them simple equations. Now, solving linear equations by multiplying or dividing. Just like add and subtract, which are inverse operations, you can multiply to both sides of the equation to keep it equal, or divide the same amount from both sides of the equation to keep it equal. So let's look at the examples. For A, we've got negative n divided by 5 equals negative 3. Well, we want to get the n by itself. So what I see is we are dividing by a 5, and we do not want to be doing that. So we're going to multiply by 5 on both sides. That's the opposite. Multiply by 5, divide by 5, reduces to 1. So we've got negative n equals negative 15. And if we don't want that negative out in front, that's actually a negative 1 n. We just divide by negative 1. N equals 15. Okay, I'm writing all over my paper here. On B, we've got pi x equals negative 2 pi. If we don't want the pi next to x, next to each other means multiply. So to undo that, we divide by pi. Pi on top, pi on bottom reduces to 1, so we don't have to write it. Pi on top, pi on bottom reduces to 1. Leaves me with the negative 2. 1.3z equals 5.2. Get rid of the 1.3 by divide, because next to means times. So that reduces the 1.3s. We got z equals. Now 13, let's see, 0.13, 5.2. Just draw that straight. Remember, you take the decimal to the back. 13 into 52, well, 4 would be 40 at least, so 4 times 3 is 12. 4 times 4 is 4, plus 1 is 5. Oh, look at that, went perfect. 4 times. Okay, we can check our answer. 1.3 times 4. 12, 1, 5. Bring the decimal one place, 5.2. Checks out pretty good. Awesome. So those are properties of equality that we can use to solve simple equations. Now, solving real-life problems. Real-life problems means it's a word problem. Read it slowly and with feeling. As you go, write down, underline, highlight things that are important, things like numbers and units. Write down the question they want you to solve so that in case you do a lot of math to find it, you don't circle the wrong part. So, for instance, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. So there's important parts. It's a 200-meter dash. That's a distance. It's 19.32 seconds. That's a time. We have to write and solve an equation to find his average speed. Find average speed. To the nearest hundredth is important of meters per second. That gives us a unit. Now, some of you might be familiar with speed. You're used to your car where it's miles per hour. And you've noticed on the little odometer that miles per hour is like this. mph, that's a division, it's a fraction. That's a way to find your speed. Okay, this is distance. And this is time. So speed equals distance over time. Now they did give us a little reminder over here. Distance equals rate times time, where r is your rate or your speed, but that solves for d. We don't want to find d. We want to find r, or the speed. So if we divide by t, r equals d over t, distance over time. Speed equals distance over time. So s is approximately, and you're going to do this in your calculator most likely, and it's going to have a decimal that goes on a long time, but we get 10.351. The 1 makes the 5 stay, and that's meters per second. And that was his speed, which is pretty impressive. If you've ever seen a meter stick, he's doing over 10 of those for every 1 Mississippi. That is a very fast man. Let's try one more. Now there's core concept, problem-solving strategies. All of these are great. My favorite with the exclamation points, draw a diagram. Draw a picture of it. Picture makes it a lot easier to figure out what you're doing and how to get to the answer. January 22nd, 1943. The temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees at 9:27 a.m. How many degrees did the temperature fall? Okay. Do we need the time? That's the good question. No, we just need the degrees. We're not looking at a rate. We're just looking at what's the difference in degrees. So take where you started and take away where you began. If you have negative and you're subtracting, you're going to get more negative. So it's going to stay negative, and it gets 58. We went negative 58 degrees, or down 58 degrees Fahrenheit. Either way, down is the same thing as negative. Okay, either way, either one of those is going to work. Okay.